Now, so this one, you are told you calculate the moment when the particle is momentarily at rest. That is time. The time at which this particle is at rest is when the velocity is equal to zero. And the function for the velocity, you already have the function for the velocity. Velocity is, so v equals to 0 here. 3 plus 3t minus 6t squared. Put it like that. So you can take them on the other side to make sure that this value becomes positive. Get 6t squared. This minus 3t minus 3 equals 0. So this value now is positive. 6t squared. Then you can simplify, first of all, before you even need simplify by 2. Sorry, by 3, you get 2t squared minus t minus 1 equals 0. We can solve this one by factorization. AC, our A is 2, our B is minus 1, and C is minus 1. So use that formula of product and sum. Product AC, 2 times minus 1, that's minus 2. And the sum is always equal to B, where B is equal to minus 1. B is equal to minus 1. So therefore, here you are supposed to get two numbers, the factors of negative 2. Two numbers you can multiply to get negative 2. And when you add, you get negative 1. So which are these two numbers? The two numbers you can multiply, you get negative 2. Then when you add, you get minus 1 is minus 2. 1 is minus 2. 1 is minus 2. 1. So therefore, factorize this. You say 2t squared minus 2t plus t minus 1 equals 0. We are factorizing. We are factorizing that. We are factorizing that one. So therefore, you get it. You are factorizing that. Factorize this. You have 2t is common, t minus 1 plus 1, t minus 1 is equal to 0. Equals to 0 like that. So therefore, get your value of t. So 2t, here, I'm writing here now, 2t minus this 2t plus 1, 2t plus 1, there, 2t plus 1, and then t minus 1 is equal to 0. So you equate them. So 2t plus 1 equals 0, or t minus 1 equals 0. So take this on this side. You say 2t equals minus 1 by 2 by 2. So t is equal to minus a half. And then take this on this side. T is equal to 1. So in this case, we are looking for time. Time cannot be negative. So can you ignore this? You ignore this one. You say t is equal to 1 second. That is the time when this particle is the momentarily at rest. The velocity is 0. This body is not moving. The time is 1 second. The time is 1 second. So the time is 1 second. Now, question 3. You are to define maximum speed attained. So the maximum speed, in this case, it can also be called maximum velocity. So maximum speed can also be called velocity. So therefore, maximum speed attained is got when the acceleration is equal to 0. When acceleration is equal to 0. So you get t. So therefore, get a, substitute here, 0 equals to 3 minus 12 of t. Bring this on this side. Get 12 of t equals to 3. So what is t? 3 over 12. You get a quarter second. That's a quarter second. That's the time taken. So remember the function for velocity. The function for velocity was 3 plus 3t minus 6t squared. That is the function for velocity. That is the function for velocity. So therefore, to find the maximum speed, substitute t equals to a quarter. So v is equal to 3 plus 3 times a quarter minus 6 and a quarter squared. A quarter squared. So therefore, this you get 3 plus 3 over 4 minus 6 times 1 over 16. So this becomes 3 over 8. Get 3 over 8. So get 3 plus 3 over 4 minus 3 over 8. That would be the velocity. That would be the velocity. 3 and a quarter. 3 over 4 minus 3 over 8. You get it. You get velocity is equal to 3 over 8 meters per second. 3 over 8 meters per second. So that's what we talk of maximum, the maximum speed. The maximum speed is attained when this body is no longer accelerating. It is no longer accelerating. So the acceleration is 0. Sasa?
Yes.
Yes, so that's what you get that question.